Whenever you're comparing two different graphs of functions, so you have f and you have another function f of -1, f to the power of -1, then we're going to determine whether these are inverses, and if they are, then they must reflect over the line y equals x. So they must reflect over this line right here. If they don't reflect over that line, then those graphs are not inverses. So what we're going to have to do here for example 5 is we're going to need to graph values for each of these functions. Now if you notice, well actually no, that's okay. So let's go ahead and we're going to make a table of values for f of x, maybe. So f of x equals x to the third, and we'll graph over 3, and we'll graph that one in blue. So make a table of values, and we have an x and f of x. So we can plug in, well, let's just plug in -2, -1, 0, 1, and 2. So you plug in -2, you're going to get a -8 on top over 3. So -8 over 3 is a -2.7, 2 2/3. Plug a -1 up there, you're going to get a -1/3, so a .03, 0.3. Plug a 0 in, you're going to get a 0. And then plug a 1 in, you're going to get a 1/3, which is a 0.3. And if you plug a 2 in, that's going to give you an 8/3, which is a 2.7. So if we plot these points, go back 2, down 2.7, so you're going to have a little point somewhere around in here. Back 1, down 0.3, so you get that. You have 0, 0. This should make an S shape if you remember, if you have an x to the third, then over 2 up 2.7. So you have this graph. It's going to look like this. Now, in order for g of x to be an inverse of f of x, that means that the graphs must reflect over this line that goes right through the middle here. So let's see if this will work out. This is your y equals x line. So let's do g of x. So g of x equals the third root of 3 times x. And even though you have a radical sign here, it doesn't mean you can only plug in positive values because you have a third root. Remember, anytime you have an odd root, you can plug in negative values into your radical. Alright, so we'll make our table of values. Get the right color here. So we're going to have x, and we'll have g of x. So we'll still plug in -2, -1, 0, 1, and 2. And when you plug in a -2, that's going to give you the third root of -6, which is a -1.8. If you plug in a -1, you're going to find out that you're going to find the third root of -3, which is a -1.4. Plug in a 0, you're going to get a 0. So we know those points are the same. And actually you can tell right now that if your points are or are not the same. Go ahead and plug in a 1, and that's going to give you a positive 1.4. And plug in 2, and you're going to get a 1.8. So if you plot each of these points, go back 2, down 1.8. That's going to be about here. Back 1, down 1.4, so it's going to be around here-ish. Then you have 0, 0. Go to the right one, up 1.4. And then if you go to the right 2 and up 1.8, you're going to have something right here. So when you finish plotting this graph, you're going to end up with something that's going to look like this. Which looks like it's going to reflect over your y equals x axis. So since those reflect, then we're going to say, yes, these are a function, or inverses. And there you go.